Hello and welcome to Moxa's webinar, Get Connected, Modbus to Ethernet. I'm Martin McHugh, and I will be your moderator today. If you have any questions at any time during the webinar, please use the questions pane by simply typing in your question and clicking send. At the end of the presentation, we will do a Q&A session and take as many questions as we have time for. We will follow up with any unanswered questions after the webinar. Okay, let's get started. We will have a 30 to 40 minute presentation with 15 to 20 minutes of Q&A. Today's presenter is Paul Wacker. Paul is the Product Marketing Manager for the Industrial Device Connectivity Group here at Moxa. With that, I will hand it over to Paul.
Hey, thanks, Martin, and good to be here today. And thanks to all of you joining us today. Thanks for, I know you have busy schedules. Thanks for joining us. We think we'll have some great information for you today with today's webinar. And with that, I think we'll go ahead and get started. And let's get this underway. Again, we've got about 45 minutes worth of material here for you. If you have questions, we do have a way to capture those. We're going to save those questions for the end of the session, and we'll have about 15 minutes or so there to go by to go through those. Let's take a look at what we're going to cover here today. And in that, there we go. My computer's a little tired this morning. In that, we're going to cover just a little bit of background here. We're going to talk a little bit about, we've got a diverse audience here today, talk a little bit about some of the different aspects of Modbus communications, look at some of the solutions to get your serial devices onto Ethernet, and then go into some common applications to give you ideas of how this technology can apply to real-world problems, such as some of those that you might have, and then look at some advanced features. So a lot to cover in the short time we have here today, and I think it'll be a really good session today. With that, I think a great place to start is to stop and think about, you know, where we've been here in, just say, the last 5 to 10 years. And when we talk about industrial automation trends, we're really talking about a bunch of different types of markets, spanning everything from, you know, oil and gas applications to factory automation applications to a number of these. And I think independent of what specific industry you're in, you've probably seen some of these trends in the last 5 or 5+ years of you know, some real challenges. You know, whether you're an end user, whether you're an integrator looking to help end users with their projects, or even an OEM you know, providing equipment that goes into some of these markets, I think there's a lot to consider. You know, most importantly, just this installed base of diverse equipment that's out there. A lot of that now having more needs for communications. And I think one of the interesting things, and I think we all forget how much this has changed recently, is this past experience where the major controls vendors wanted to keep you within their distinct ecosystem. So, for example, if you were going to buy brand AB product, and you wanted to be able to connect that to, you know, your favorite flow computer, or pick you know, a PID controller, you had to stay within their ecosystem with which to do that. You know, that's really changed, and you know, that was once a problem, and there's a number of ways to which to accommodate that nowadays. If you're more of an end user and you're responsible for operations of your facility, you know, certainly one of the things that's very important is you know, how can we do more with less? How can we get more efficiency out of what we have? Or what investments do I need to make to, which may be small, to make a significant impact on the bottom line of the operations? Or, you know, what about this trend? And I think all of you in various ways can see this. You know, look how the internet has impacted our daily lives in so many different ways, not just from the social aspects, or, you know, that mobile phone you carry in your pocket, but how that's changed the way we do business, from both a operation standpoint as well as working our way back to manufacturing. And you know, also that kind of gets coupled with this rapid adoption of Ethernet. You know, if we had looked back 10 years ago and asked how many of you folks are using Ethernet, it would be a small fraction. Today, you know, everybody's using Ethernet in different capacities. It's just a matter of where you're at within that adoption cycle. And lastly, you know, and I kind of alluded this to earlier, is when you look at how we solve problems today, it's become more of, you know, how do I find the best-in-class solutions to help me solve my problem? and it's not always easy to do. It's getting easier, and we want to talk about some of those things today. So I think that sets the stage here a little bit for where we want to go. And then let's take a little look at this next slide, which kind of is a little bit dated here, but it's some research that we looked at from IMS Research, market research firm, that took a look, and this is installed devices looking at industrial protocols. And I think you can see, the broad spectrum, and there's some that are rolled up in this others category of all the diverse different types of communication standards that are out there. It's really challenging within this industrial space as to, how do I get my things to talk with one another? You can see some of the older established standards and more recent ones. Certainly Modbus taking a large share of that. And what you can see here is this progression of moving towards Ethernet, right? So where we've had all these splintered, fragmented, special purpose needs, we're finding that these are moving to Ethernet. And we'll talk a lot about some of the reasons for that. But you'll see very easily that there's some real compelling reasons to do this. And of those, the number of choices have really kind of solidified into a couple of categories. The one that was the biggest market share up until recently has been Modbus TCP. If you're not familiar with that, don't worry, we're going to talk more about that. Shared with some of the things here within North America as well as worldwide use with Ethernet IP from Rockwell and Profinet more from a Siemens standpoint. With that, I'd like to get a chance for you folks to participate here today. And I know we've got a really diverse group. If we could, Martin, let's go ahead and take a quick poll with our group here today. And to kind of frame this, and it'll be helpful for me, what's your familiarity with Modbus? And if you just take a few moments to click on the survey up on your browser right now, it'll help us tailor the rest of the session. And I know we've got a pretty diverse group. We've got a couple questions in there which will give me a little idea of your level of expertise. And we have a little fun response back there. We have a couple of Modbus gurus with us today. Keep me on my toes in terms of answering some of these questions. It'll be good to know. And Martin, how are we doing there? A few more moments? Okay. And can we see the results on that? Okay, great. So we got a pretty diverse group here. So with that, I do want to spend a few minutes just kind of going into some Modbus basics. And for those of you that have a little more experience on this, bear with us. We'll cover some background, and even if you have some experience, I suspect that you'll probably find, there's a couple of things that you didn't know about this that might be helpful to frame our discussion for today. So let's take a quick look at that. Now, interestingly enough, I think whether by design or whether by sheer chance, some of the things that have happened with Modbus are really good examples of what manufacturers should do as we, go into this new standard of Ethernet and IP networks. It was first conceived of by Modicon. Modicon, as you know, was the first company to build a PLC. Some of you may know about Dick Morley, known as the father of the PLC. They had some bright ideas to not just keep this proprietary, but actually make this available to the public in 1979. And that's really become the de facto standard for communications, and it's why we see so much of it still present today. For those of you not familiar with it, it utilizes a master-slave architecture, meaning that one device is going to be requesting information from others on in your system. So masters will use a message-based structure with which to do that. And it basically has two basic things they can do to read and write different devices, read and write different data types from these specific devices. So, and we'll go into this a little bit more in the next slide to give you a little more clarity on that. Now, Modbus, when it was first implemented, was done with a RS-232 serial port, with RS-232 being, used for point-to-point connections. That was great for simple things like downloading a program to a PLC or being able to see what's happening to debug your PLC. Then the idea was, how can we take this and do this with multiple devices? And with that, you have master-slave architecture and the ability to read and write devices with that. So again, first implemented with a direct connection point-to-point with RS-232 serial port, and then later they had the bright idea to adopt this to be able to have multiple devices. So it was really one of the first ways to do industrial networking utilizing RS-485 technology. We'll talk a little bit more about that in a few slides, to do multi-drop connections. And then more about that a little later and how Ethernet came to be used with that. So again, one of the really great things that I really think set the precedent for other manufacturers to adopt is releasing this as an open standard. So here's how it works, here's the specification, it's free to the public. And that's one of the real driving forces today as to why it's became such a huge established standard for networking on that. So a little more about that master-slave correspondence here. If you take a look at this on the upper right-hand corner of the screen, you can see a little bit about how this works with both the master and the slave. In this case, we're kind of showcasing that with an HMI being the device that's requesting data here as a master from the slave, which in this case is the PLC. So again, masters ask for information, and the slave says, okay, here's what you asked for, here's that data. When we do this, there are a couple of things that have to happen. And if you kind of look at the information that's going across the wire, you'll find that these requests contain a couple of things. We have to identify what it is we're looking for, which is called a device address. We have a function that says what we want to do with that. There's some data exchange, and there's also some error checking. So it's a pretty robust, we call this a protocol, pretty robust protocol, and this is kind of the basics within Modbus. And if you look at other industrial protocols, they share a lot of the basic core things that happen here with them. Another important concept with Modbus is even if you have a point-to-point connection with RS-232, that each slave device on your network has to have a unique device address, sometimes called a slave ID. If you're setting up a network, or some of you that have done this before know about this, you have to identify each device with this slave ID. It may default to one from the factory, and based on your application, you may use that, or you may reassign that as you configure your specific application. So that actually is a number that ranges between 1 and 127, and please be sure not to use addresses 248 through 255 because these are reserved, and there are some special uses within some types of software, and you don't want to use those for your application. And lastly on this, while it's not used very much anymore, there was an early standard called Modbus ASCII. It is very rarely used anymore, and if it is, it's quickly being replaced by Modbus RTU. It utilized a easier to read format that was not as compact as the current standard. RTU stands for Remote Terminal Unit. It's the most popular. It uses a binary address and data format that's more compact, meaning that it takes less resources to send the message, and you can get a faster polling cycle and see updates a lot quicker. Okay, so key concepts here: master-slave orientation, as we have with the HMI and the PLC in this. We have certain things that are exchanged. Each slave device has an ID, and most often folks are using in this the Modbus RTU for what they're doing with that. Okay, good. Next slide. There we go. I was waiting for it to come up here. Let's go a little bit more into those devices, right? So this is a little bit Modicon speak, and it's carried over if you're using Modbus. You have a couple different types of things that you can do with this, right? So if you think about PLCs, they typically have inputs, which are contacts. I just noticed it should be coil is the output, contact is the input. A little typo there. And those are on-off status. You also have inputs and registers and holding registers. These are a little different type of data type. Those can hold analog values, such as a tank level, a pressure in a vessel. It might be number of cycles on a piece of equipment. And these are all denoted by different device address ranges. So if we're talking about coils, 1 through 9999, contacts have a different address range, input registers and holding registers all have different ones that are being used for this. With that, there are also different function codes associated. So when we do things within Modbus, we have different types of requests that can be sent. And we can read contacts, we can read coils. All of these have some different function codes. So if we talk about function code 16, for example, here, function code 16 means that I want to write to one of my Modbus devices, and I want to do register values. So I want to set a position for a new hydraulic cylinder. We might do that through that function code. Okay, so pretty important stuff to have. Now, when we talked about that master-slave response, this is a little bit of a timing diagram here, if you will, that will give you a little feel for, what happens with these things. So your master is going to send a request out to your slave. It might be, hey, tell me the tank level you have in that vessel over there, and that device is going to respond back and come back to the master with that. So real simple, sends a request, and a response comes back, right? Now, there can be a problem where you might have a mistake with that. And in the case of maybe it was a configuration error, maybe you're sending a request to this slave that's not supported by that specific device. In that case, the device may respond back with an error code. And you typically see this from your Modbus master or your SCADA system or your programming software for your PLC, where you'll get an exception code on this. So that's one of the nice things that Modbus has, the ability to handle these types of exceptions and do that within your application. Now, a little bit about wiring. I think it's important here that to know about how to set these different systems up. Again, I talked a little earlier that when you do Modbus, you have a couple different ways in which to do this. Most of the applications are going to be RS-485, but it is possible to use a point-to-point connection with RS-232. Today we're actually going to do a little demo for you to kind of show you what one of those looks like, and I'm doing a point-to-point connection with that. So RS-232 would be one master and one slave, much like you'll see in our demo here today. So one master to one slave, typically with 232. If you want to have more than one device, you have a little more complex configuration here using RS-485. RS-485 has some unique abilities in which you can share amongst multiple devices a pair of wires. Some people will call it multi-drop or cascade. Basically, it means that that master has the ability to talk and to read and write to many different slaves. Now, if you're not familiar with RS-485, it's an existing standard that basically defines the electrical characteristics on being able to share a single pair of wires that allows you to actually not only connect multiple devices, but actually do quite long distance with those. It uses differential signaling, which overcomes some different common mode types of noise that you can have on a network, and basically allows you to overcome that distance limitation you have with 232, which can be about 25 to 50 feet, and go lengths up to 4,000 feet with that. It allows you to have up to 32 devices, and that can actually be a little more based upon your actual application, but in general we typically see about 32 devices max, one of those being your master, so one master, 32 or 31 slave devices that are out there. And please bear in mind that only one can talk at a time. I typically use the example of, many of you might have, two-way radios in your factory, or maybe have used a walkie-talkie at some point, where, if you have multiple people pressing the button trying to talk at the same time, it just doesn't work. It gets garbled and nobody's message gets through. RS-485 works the same way. So only one device can talk at a time, and we do this through the master controlling access. So the master sends a request, it turns off the transceiver, waits for a reply to come back, listens for the reply, and only after the reply can it talk again. And you can see a little bit here for those of you that maybe have a little engineering background or maintenance electrical background. You can see the master over here on the left having both the transmitter and receiver sharing a common pair of wires amongst these devices, and then each slave being able to receive and transmit by controlling its access to the network. Now understand this works a little bit like a shared media. And much like if you've done any RF work, it has a requirement that you have to terminate the ends of your network. So both on your master device as well as the furthest end, we have a termination resistor. Make sure that when you're setting your networks up that you have these installed. And you may also have to do some biasing based upon the specifics of this. And lastly, one thing to make sure of is that you do use the proper wire. You do want to use not Cat5 cable for this, but twisted pair that is 120 ohm impedance that's specially designed for this. If you have questions, contact, if you're working with a distributor or contact, one of us here at Moxa. We can help guide you to use the right type of cabling for your network. Okay, good. A couple important things there, and just to understand that 232 is point-to-point, 485 you can get multiple devices on your network. Okay, so with that we've taken just a real quick look, and for those of you that have background here, thanks for bearing with us, that when you talk with Modbus RTU on a twisted pair wire, whether 232 or 485, there are some limitations, right? So when we talk about this, you've seen that the Modbus standard says that we can have up to 247 slaves. The real limitation is that we're limited by the RS-485 standards. So in common practice, you're probably looking at one master, 31 slaves, giving you 32 total devices for that. There are ways to work around that. We're going to give you some of those ideas here today, how to do that. And keep in mind there's some limited distances, right? Those limited distances can range from what you use for your physical cabling. And while I didn't go into specifics, there are some ways to extend even beyond that RS-485 standard. There are ways you can extend your serial connections over fiber. There are ways you can do a leased line connection through a telephone company, or in some cases radio modems. However, we see that those are kind of old technologies, and Ethernet has been a preferred way to do that, and we're going to share with you more ways in which you can do that. And then lastly, because this has been architected for serial links, there's some real limitations on what you can do with your data. So you'll find that there's, and maybe some of you face these same problems in what you do, right? Being able to, now I've got this data, how can I do more with that, right? How can I do more productive things and know more about my manufacturing process by sharing this data and looking at it more closely? The real limit is that when you have this single Modbus master limitation, whether it be a SCADA system or an OPC server, whatever it might be, you're really limited to what you can do that. There's no provisions for doing remote diagnostics at the same time your SCADA system's running. And if you want to have a real robust system and have the ability to have multiple SCADA servers, it's really a challenge to architect those types of systems without really doing some difficult things to do when you're working with direct serial connections over RS-485. So with that, let's take a little look here at how some of that's been solved by moving to Ethernet. And let's also talk about some of the extensions that were done. And I think the exciting thing is that the Modbus protocol was a real simple protocol, and because of its simplicity, it made it easy to do some things. One of those things was some early adopters said, hey, we understand some of how this works, and there was some pre-standard things done by people that had a good understanding of Modbus and really had a good grasp on Ethernet and IP communications. And what they did was take Modbus RTU and just put it inside of a TCP IP packet and move it over a network. Some of that still exists today, and even some of the OPC server manufacturers have a way of doing this. And I wanted to highlight this is not part of the Modbus TCP standard, and be a little careful with this because the Modbus TCP standard is actually a different protocol that was actually standardized in 1999 and available. On one of the previous slides we shared, modbus.org is a great resource for this, and I encourage you, if you have questions after today's webinar, that you check out modbus.org, go to the resources page, and there's some great information there for you to take a look at. Now, to go a little more specific into this, Modbus TCP means that now we address devices by IP address, which is their unique name of a device on a network, and that if you remember if you've had some basic network training or have had some experience, that to identify devices on your network, much like if you have a phone system, so if you were to call the main number here for my office here at Moxa, whether sales and marketing headquarters here outside of Los Angeles, you might need to get to my desktop extension. That's like a port number. So port number is like calling a main phone number and then going to that phone number extension. And that allows you to get to a device that natively supports Modbus TCP. And then when you look at it, what was added with this Modbus TCP standard is a couple of things that are added to it. So the basic Modbus protocol had these, the slave ID or address, the function, the data, and some error checking. The Modbus TCP standard added some other things that can help us do some more important and more powerful things that you'll see a little bit in a few minutes of how this all falls together. Something called a Modbus application header, or MBAP. So bear with me on that, and we'll come back to that in just a few minutes. Real important to see that. So let's take a little brief pause. We've covered a lot of basics here with Modbus RTU. Some new things for some of you. Again, if you'd like to learn more, we've got some great resources here we can help you with, or that modbus.org is a great resource. And we've talked about, how some of these past standards are a real challenge for us looking here towards the future. And, if you've got these assets, if you're an end user and you've got Modbus devices, how do we take advantage of those and not have to rip them out and replace them, because we know that's a difficult proposition for you to justify doing. If you're a systems integrator and you're trying to help one of your end users or do a project where you have to coexist with this, how do you preserve those existing investments that you have, and how do you bridge between those old devices and new? And specifically, if you're trying to do this, if you're an integrator or even an OEM, how do we pick a best-in-class solution that really solves the problem for multiple parties involved? And when you look at this, there's a lot of different solutions. Many of those require being a skilled programmer and doing some things within your programming in which to be able to do that. Not everybody has that skill. Not everybody has the time or the wherewithal to do that, and it can also be kind of an expensive proposition. How do you do that? So let's take a look at that. And I think as we do, I think it would be great if we could take just a few moments here and toss it back to you, those of you folks that are joining us today. And Martin, let's go ahead and do a poll on this. Do we have that up on the screen? And I think we do. Let's get a little feedback from you. I know some of you may have already kind of thought about some of these problems that we're talking about today. I'd like to get some feedback from how you've approached it. And if you haven't, I know a lot of you folks may have not faced this problem here today. That's fine. Let us know that that you're still thinking about that. And hopefully after today we can give you some ideas on a couple approaches to do it. Some of you may have done some other things and maybe even thought about some things that aren't on his slide here today. Take a moment to share with us your experience in doing that. To do that, and we're going to go into a lot with one of those options. And Martin, are we close to closing this one out? And I think we are. And here we can kind of see the results. So as I kind of expected, a pretty good mix on some solutions to this. And I'm a little surprised we didn't have a few people responding that they've used an industrial PC for this. And we also see that we've got some people that know a little bit about the rest of our discussion on utilizing industrial Ethernet gateways. So Martin, I think that's good. Thanks for sharing that. And let's go ahead and go back and delve into that a little bit further. And even if you have used a gateway, I think it's really good to look at some of the things that have kind of been developed here in the last few years. There's a lot that's happened, and it's not a stagnant technology by any means. Let's define what that is. So if you did answer, here's what that looks like. So basically, it's a specialized device that you can insert, in line with your asset, whether it be a PLC or a variable speed drive. I'm showing an example here of a very commonplace item that's a three-phase power meter that's used in a lot of industrial applications to measure how much power is being consumed by equipment. And this gateway sits in between that actually bridges these devices together between your serial asset on Modbus and, say, for example, this PLC over here. And the neat part is this gateway is able to do a translation amongst these different devices. So let's go into a little more detail of what that looks like. Now, some of you may know a little bit about Moxa, perhaps from past experience. Our heritage, about 27 years, has been helping folks like you connect your serial devices to Ethernet. And we were one of the first to market with something called a device server. Basically, it's a small box about the size of the current generation, about the size of a deck of playing cards, that take most any serial device and get it on Ethernet. And they're really kind of exciting when you look at what's inside of these guys. And we've got a custom 32-bit ARM processor in there that runs a full embedded Linux operating system with special application software that can take any serial data, put it into an IP packet and move it across the network. However, this type of technology is real agnostic to the data it's working with, and it's kind of horizontal. If you were to take something like a scale on your plant floor and connect that to one of these device servers, you can move that remotely across the network to another device or do some useful things with it. Now, remember we talked about that pre-standard use of Modbus over TCP. If that's your intent, you can use something like this to simply encapsulate, or we say tunnel, to take that raw data and move it over a network. No protocol conversion, raw Modbus RTU over Ethernet. There are some caveats with that. You can only do point-to-point connections. You're limited to one device and one master. There's also some caveats in terms of timing. You got to be a little careful of setting this up because of the way Modbus works for an end of message, which typically is 3.5 character times. So if we're talking about 9,600 bits per second, that's about a millisecond per character. So at the end of that message of 4 milliseconds, you've got to be able to stop that communication and let the master take over. So again, if you need help on that, let us know. We can show you how to do that. But certainly a challenge for a lot of folks, and not what everybody needs when they talk about Modbus TCP. So that function of the gateway looks like this, and we call this a transparent gateway because it works like this, whereby you've got the gateway, and it sees a request coming in. That request may be coming from your SCADA system over here, so we're talking about the SCADA host sending the request. Let's read that register 40,108. It goes through the gateway, does an on-the-fly conversion, goes out to your attached device out here. That attached device is going to say, okay, here's your power value from that power meter. Here's how many watts we're consuming. And after that, that comes back through the gateway doing an on-the-fly conversion from Modbus RTU back to Modbus TCP, basically, giving you your results for this guy. And we call that really an on-the-fly protocol conversion, right? So we're going from TCP through the gateway, doing the on-the-fly conversion, getting the data from the attached device and coming back. Looks pretty simple here on the slide, but when you look at what's happening inside the product, it's really neat that it makes it so easy and so transparent to what you're working with which to do this. Now, here's kind of another example, and we're going to just segue here and do just a brief little demo. And what I wanted to set up is, how this looks. So here's that same example of having, your Modbus master going through a switch to your gateway in the system, and then out to the device. Again, we would be the most common operating mode for this to actually do this type of application for that. And just to kind of give you a little better idea on here's how you can take that device and specifically in your application be able to get that on Ethernet and now access it from your software, whether it be SCADA or OPC server, with which to do that. Now with that, and Martin, well, I'm going to go ahead and move over to a quick demo here, and bear with us, folks. I'm going to go ahead and just share a screen on this with that past day application example, and I'm going to move over to set this up. And we're first going to take a look at what the configuration might look for one of your gateways. Now, there's really only 3 things to set up on this to give you an idea. And no matter which gateway, if you're using a transparent type gateway, here's what you can expect. I've got one set up here in our facility, and this is what it might look like if you were to point your browser at it. And basically 3 things we're going to set up. We're going to set up network settings, we're going to set up an operating mode, and we're going to set up the serial port settings. So let's kind of come into here and take a look. Within these settings, let's first take a look at the network. Now, different ways to do this one. In my environment here, we're using DHCP, which lets me use an internal server on our network to allocate this device. A lot of you may end up using static IP assignments, which means you have to manually track the unique identifiers or the IP addresses of your devices in the network. You also see an important thing on here is also a network mask or a net mask, and that's a way that you can do routing on your network. So when you do a request, it knows whether it stays on that local subnet or it has to be routed to somewhere else within your facility. Most people will typically have a fairly small network, and utilize something similar to what we have here on this one. So we got that set. Next is we want to set the operating mode. Now on this one it's pretty simple, and most all of you are going to do something here that you're going to select RTU slave. This means that on your serial port that you're going to see that it's an RTU slave that is attached to this, right? That means in this case I've got a PLC attached, and that's what we're looking at. And then lastly, we're going to set the parameters for that. And in my system, I know the device that I'm hooking up here. I've got 9600 bits per second, even parity, 8 data bits, 1 stop bit. And we're using, real important here, often folks forget to check this, we're using RS-232 on this one, right? So I'm doing one of those point-to-point connections with it. And you click Activate, which would go ahead and do that. Okay, I've got it all set here. I'm not going to make any changes. Now, how do we test this? I'm going to change my screen over to a little application that we like to use here, and it's from a third-party company called Wintech, called ModScan32, and you can get this as a free download from their website. If you have another tool that you prefer, there's a couple out there. Also, I'd recommend modbus.org has some resources that you can go to look at third-party software out there. And I've actually got this one running here already, but let me just kind of, I had it running and forgot to disconnect. Let me just kind of reconnect and show you what it looks like here. I'm going to go ahead and do a connection, and to show you what I'm going to do here, I'm going to connect to this remote Modbus device. You just saw in the previous settings that I have an IP address assigned for this, and that's all you need to do from your Ethernet side is say, go to the Modbus device, here's the IP address of the device I want to go to, and then let's go ahead and connect. And then when I connect, I'm going to define the devices I want to look at. Within this specific PLC I have, and I'm using a little Modicon Momentum, now available through Schneider Electric, that the Modbus registers are going to be holding registers I'm looking at. They start at address 10. I'm going to look for a total of 4 registers. And you can see live data here on the bottom, hopefully within your browser window, of live data coming up from the PLC. You can see just a couple registers rolling through those, okay? So your actual application might be a little different, but you can see live data coming from that serial device. So real briefly, I think you can see within a few minutes you can set up your device. Of course, I simplified this and didn't show you the wiring that needs to take place and knowing the specific parameters of your device. But with that and having your gateway, setting up your network settings, setting up your operating mode, specifying your serial port settings, and then pointing your software to that specific device, I think you can quickly see you can get that serial device within 15 minutes up and going on your Ethernet network and collecting data remotely from, whether it be your programming software or whether it be, your SCADA system, HMI. Very easy to do this, and a pretty powerful tool with that. Okay, good. So let's kind of come back to the presentation slides and look a little more. And I think that I had one more slide here. Let's go to the next slide. I think here's the actual example. I probably got ahead of myself a little bit, but you can kind of see the scenario we had set up here with our gateway acting as the means to be able to connect between Modbus and get to the PLC that's our field asset here that we're connecting up with that's on there. Okay, great. So I think a lot of you might have some ideas on how you can apply this type of technology to your application. And if you don't, and I know that when we took the poll a little earlier, we had a lot of folks that didn't have a lot of experience working specifically with the bits and bytes within Modbus. So let's take a look at a couple of scenarios. And I've just got a few, and I wish we could show more, but within the scope of what we can do today, let's take a look at a couple of these. One application, and I think you saw that power meter on here, we find that there's a lot happening nowadays with folks looking at doing energy efficiency. And to be more efficient with your energy usage, you have to know where you're utilizing that power. And a lot of systems within building automation, this even kind of overlaps within plant floor applications where you've got your power coming into a facility and have your switch gear. It's gotten quite commonplace to instrument that with a 3-phase power meter installed within those panels. And even today, and I'm using the example of a formerly Square D here in North America, known now as Schneider Electric power meter, these are new devices. They don't have an Ethernet port, and you can only get at them with a serial connection. So if you want to get at these more than a couple thousand feet using RS-485, you need to have some way with which to do that. Here's a great solution by being able to tie that together and bring in those assets from your sub-metering within your panels, back into a control center where you can go ahead and monitor what's happening. And if this is merged within your group in a facility, whether it be a control room or even with a data center application where there's critical power needs, a lot of the larger commercial UPS systems also have options, whether or not built in or an option card, to be able to monitor an uninterruptible power supply via Modbus on this. So great application on how you can instrument the existing systems and bring that into your control center to be able to measure your energy usage and be more efficient at how you use that and find out what you can do to conserve energy and be more efficient at that. How about a more traditional application for factory automation? Here's an application where the need was, hey, we have HVAC that supports our operations in this facility, and we want, kind of following along with that same theme of really wanting to have some energy efficiency. How can we control those systems and not just run at a consistent speed throughout the day? How can we be able to change that based upon the demands and vary that as the needs arise? So this had the existing HVAC systems with a variable speed drive installed, and some of you folks that perhaps have experience working with variable speed drives, VFDs, inverters. A lot of these have, and almost all these have Modbus built in with a communications port that's used for initial setup. And all you need to do is be able to plug into that Modbus port on RS-485, come in through a gateway, and now you're available on Ethernet. And actually, I've done this myself. It's really hard sometimes to pull the covers off and get it down into the side of these to add those option boards. And on top of that, those option boards can be pretty expensive. This is a nice way to drop these on the Ethernet very quickly and easily and be able to get that onto a much wider level network. A lot of times we're finding that these networks are already in place, so it's not difficult to drop a drop into where that panel is with Ethernet and very quickly pull this all together. How about one more application, then we'll move on here. Hopefully this is giving you folks some ideas of some of the things you can do. And by no means are these a limit. I could probably go on for an hour just talking about some of the things that we've seen done with this type of technology. This one being used in an application for PV solar photovoltaic power plants. Some of you may have seen these on commercial buildings. I know that it's been quite commonplace for this. Here at Moxa, at our global sales and marketing headquarters, we've got a real large system that's on our building that actually helps us to meet our power needs and is an important part of what we do. And I know personally from our experience, one of the things that's important is being able to know how efficient your system is. We recently had, a few weeks back, a couple of fires within the mountains nearby here in Los Angeles, and with the soot that happens from that, that can settle on the solar panels and reduce the efficiency. And the only way you know about that is by being able to know how much power is being sent to you through the sun and how much is being produced. So you might use something like a pyranometer here to measure solar radiance, and by knowing here's how much we should be receiving and here's how much we're producing, you can find out that there's a problem within your system. That could be dirty solar panels, it could be a number of things. This was actually used in a large commercial project used here in the southwest of the U.S. and being used to monitor efficiency within that plant. And this worked out to be a really nice application. So hopefully that gives you some ideas of some of the different things that you can connect on these guys. So let's go a little further. Some of you folks measured that you'd actually done some applications with gateways, and let's take a look at some of those. Now, we used the example of having the Modbus RTUs being only on the serial side. You can actually use these in a reverse configuration, and it looks like this. So if you've got an HMI and the HMI only talks Modbus on serial, you can use this in a backwards configuration where you can have that HMI pull data from an Ethernet connected PLC. Pretty useful way, and again, just all you need to do is go into the mode settings and change that within your gateway. Another thing, and some of you may find, and we find this today, even though we see a lot of folks that have moved to Ethernet, there's still legacy software out there that has can only address a COM port. If that's your situation and you have software that can only address a COM port, and we're talking about getting things on Ethernet, how do you get that software to work across Ethernet? Well, we have a technology called a virtual COM port, and that virtual COM port technology basically consists of a Windows driver. We call this Procom, and that Windows driver can create a virtual COM port that gets redirected over Ethernet to your gateway. So if you've got SCADA software up here that utilizes only a COM port, you can create, say, COM number 4. COM number 4 would go across Ethernet to the gateway and could go across to either serial or Ethernet attached devices on that gateway. So again, an interesting technology that helps you kind of bridge the old and the new. And if you're stuck with legacy software that doesn't support Ethernet, here's a way to upgrade it to be part of that. Another common thing, just real quickly, here are a couple of possible installation issues you might have. And it may be misconfigured settings, and how do we do this? Well, basically, one of the things that you should know about is these types of gateways have a lot of diagnostics information built in. So let's take a quick look at how we can do that. And I want to take just a quick look at another little quick demo. We'll keep this brief to show you kind of what you can do here, and look at what you can do with one way to do that. And let me get the right application here. I'm going to pop over to an application that we also use. You saw the web browser setup. We have something called mGate Manager that you can also use. It's a Windows utility for setup. And basically, it has an ability that you can go out and scan for devices that are on your network. And I want to do a monitor here. So I'm going to simulate a problem on my end here, and you can't see this. So you're from your desktop trying to troubleshoot something remotely. And let's see if we can figure this one out. And I'm going to click on, I've got somebody at the plant that says we're having a problem, and from my desk I click on Monitor. And Monitor is going to pop up a window, and I say Start, and let's see what happens here. Oh, okay. So with this, what we can see here is we have a request coming in on Ethernet via TCP. I see that out of port 1 of my gateway, I'm sending a request on RTU, and I see no response coming back. So again, coming in on Ethernet, going out serial, and since we know that the request response protocol, we should see something coming back, and I don't see it. This tells me that I've got a problem between the gateway and my attached device. Nice little thing here. I'm gonna clear this, and let's fix the fault. And what I've simply done is I've unplugged the cable to that PLC. So let me plug this back in really quickly. Let me give it a moment just to kind of come back and polling, and let's run that test again. And after fixing this, now you can see the correct thing that's happening here. Here's the request. Here's it being sent out the serial port, and here's that important response coming back from that attached device. And if you're a little curious, you can also see the specific request going. Here's the read request, and here's the response coming back. Okay, I think that gave you just a quick idea of some of the neat things you can do when you have a capable gateway to help you do some troubleshooting on these. Okay, let's kind of summarize here a little bit, and I want to get to Q&A. We're just a few moments behind. Thanks for bearing with us on that. Just to summarize, and I hope you all got something out of today's webinar in terms of some of the things that you can do by learning from what we've been able to share and some of our experience we've gained with working with serial ports and specifically with these industrial protocols like Modbus. Gateways give you a really easy way to take those RT devices and get them on Ethernet. You don't have to replace those devices and buy a new one. In some cases, like the Schneider power meters, you can't get them with Ethernet. You've also found that it's real easy to do this. You don't have to be a programming expert and change programs in those attached devices. It's really a drop-in networking solution with which to do that that doesn't take any programming, and it gives you the option to be able to find the best-in-class solution to do this, right? So you can pick the best gateway out there that addresses your needs and be able to fit that with your preferred control solution. And for example, maybe you've got experience doing Modbus TCP. It lets you kind of do a best-in-class solution for this. And one part that I didn't have a lot of chance to go into is this redundancy. Understand here that on the gateways, that the gateways will actually support multiple hosts talking simultaneously to that shared serial asset. So where I had the ModScan software simulating a SCADA host, that gateway has the ability to be a traffic cop, and I could have up to 16 different hosts talking to it at the same time, and it'll multiplex between those, meaning it's really easy to have redundant SCADA hosts on Ethernet. And to understand, too, that while today's topic has been to talk about Modbus specifically, that this whole concept of industrial Ethernet gateways can be applied to other protocols. If you have needs that go beyond just Modbus, and say, for example, you're doing a lot of work with Rockwell PLCs or Allen Bradley PLCs and need to get to Modbus, or if you use Siemens Profibus and Profinet, we have solutions for that as well. And then lastly here, and we'll open up here to questions on this. As you're planning your network projects, don't forget about the Ethernet infrastructure as well. And I know one of the challenges we found is that oftentimes, customers such as yourself are thinking about the end devices and kind of forget about how do we instrument the network architecture. And if you're using Ethernet switches, hopefully you're selecting managed switches, which give you ways to look at performance and availability of your networks. That it's not easy to take a traditional Ethernet switch that only supports simple network management protocol and get that into your system. The conventional approach is to throw a embedded PC at that, or use a OPC server to pull SNMP, which is that simple network management protocol, out of the switch into your SCADA system. But rather, look at other things. If you look at a true industrial switch, they have abilities to be monitored and managed remotely via Modbus TCP. Now, while you're focused on moving towards Modbus TCP, you can also look at performance and availability of your switches. And let's say, for example, you had a breaker trip in that panel and lost your Ethernet connection to a PLC. You can remotely see that on your HMI if you have that set up for that. With that, and thanks, we got just a few moments behind schedule, but I think we caught up. Martin, I'd like to open up to some questions, and if you'd be kind enough, I think we've got a couple queued up. Let's open that up and tell me what we have.
Absolutely, Paul. All right, so now we're going to open up to questions. I do have one here from James. James asks, I need to access equipment at several of our factories over a corporate network. Can I do this with a gateway? Paul.
I'm thinking there's probably a little more in that question. He's being short, but I'm thinking that must be over a wide area network within their organization. And absolutely yes, with gateways, they give you the ability to get that serial device with limited connections onto Ethernet, and that will allow you to move that, whether it be a couple thousand feet across your factory floor, as long as you have IP level access to that. Even if you're on a remote connection via some type of a wide area network, within your organization, you can get to it. I've even done applications where I've dialed in, or connected remotely via a laptop with a VPN connection to do this type of thing. Modbus actually works very well. It's a very lean protocol, and we can do a lot with it.
Great, thanks, Paul. This next question comes from Michael. Michael asks, what is the best recommendation that you have for Modbus TCP security? So, Paul.
Well, that's a good question as well, and I think this is kind of a one that probably was going to take more time than we could really go into as much as I'd like. From the standpoint of security, security is never just one individual thing. Like, I can't say here's a product to use to solve your security needs. It's really multifaceted. It's about training of the people involved. It's about best practices and how you architect your networks and all of these. And unfortunately, the Modbus protocol does not have security provisions on its own. And the end devices themselves, if you take, for example, the PLC I'm using here today on the Modicon, it's wide open to all of the register addresses in that. So you have to be a little innovative on this. I can share with you a little bit, and some of the things to think about on this. And maybe it's something that might make a good topic for us to talk about in the future on this, because I know a lot of people are hearing things, most recently about the heartbleed issue with SSL out in the media and how that impacts us that are involved in manufacturing. It's a real challenging thing. But James, to kind of come back to that too a little bit, I think you have to look at the devices you're working with, and if you have abilities within the end devices that you can restrict what you can do, by all means, that's a great place to start. So, for example, if it's possible in your end device to restrict access, that you can have read-only access, do that. Another way you can do that, and I'll give you two solutions that I can tell you here from first-hand experience. We have another type of gateway that we call an active gateway that you can actually do mapping of your Modbus addresses. So say, for example, you want to have read-only access to certain registers. You can set up a data table and do your mapping to do that. Also, there's some new technology we've introduced with our Ethernet switches that's called Packet Guard, and this is something that allows you to do something similar. And if you'd like to know information, let us know about that. But it's something we call Packet Guard, and basically it lets you kind of sit in as an intermediary. So even if you have a Modbus write request, what it will do is limit that to read-only access.
Great, thanks, Paul. This next question comes in from Ken. Ken asks, what would you estimate is the lifespan of a Modbus type control over PC-based flowchart type programming, or maybe other trends that you've seen? Care to comment?
Oh, and that's a real open one as well, and especially if you do control over PC. That's a whole topic of discussion on its own. It's real exciting with some of the technology we have of looking at alternatives to just dedicated PLCs, which we've had here in the past. I think, Ken, the real question is what's the longevity of Modbus out there? And I think from some of the things that we've seen from anecdotal evidence and research we've seen, that as things stand today, with the open standards with Modbus and some of the things I've seen with the larger community out there, again, I think modbus.org is a great place to go to see some of that. There's some open source projects where people are creating open source PLCs that can run on a embedded computer. There's some great third parties out there making real-time systems. And being this is a really good fit for Modbus TCP, I've got to think that we're going to see Modbus out there for at least the next 20 years in some form or another. And I think it's not going to be one protocol wins all. I think that there'll be a much smaller number of protocols that we're going to see. But the real value of this is that you as the end user can pick which one best fits your needs. And just because of the heritage of Modbus by being the first true open standard out there, and because it's so simple and easy to implement, and when I say easy to implement, you can take a little small 8-bit microcontroller and get that running to talk Modbus serial. I've got to think that we're going to see this for another 20 years out there by all means. And hopefully to answer your question, Ken, if not, I think Martin's going to have some contact information for you. Let us know. We'd be happy to try to address that in more detail. Martin, do we have another couple more questions here?
We have plenty of questions. The audience has been absolutely fantastic, and it looks like we're going to have more questions than we actually have time for, but it's a good problem to have. The next question comes in from Mac. And Mac asks, I see HVAC. Do you handle BACnet protocol? So, Paul.
Okay, here we go. Like I said, there's still a lot of protocols out there, and they haven't narrowed down enough yet. We hear about that a little bit, and so far it's not something that Moxa has had kind of immediate solution for. It's something we're looking at. If you might want to contact a soft list, I can probably give you some suggestions on other folks that might be able to help with that. It's been a little bit specific for, as you mentioned, HVAC specific markets. When we look at the larger market perspective, we've really been a little focused on the major ones. I'm hoping at some point we'll have a solution for you, but Mac, contact Marty after the webinar, and we'd be happy to try to point you in the direction of some further help for that.
Okay, this next question comes from Peter. Peter asked another generic question, but I think it's a good one. He wants to know, what about wireless applications?
Okay, I'm going to have to interpret there a little bit, but Peter, I think you're talking about, can you do Modbus over wireless? And absolutely, we've seen a number of applications doing that, and applications ranging from the oil and gas applications at wellhead monitoring, where that aspect of wireless of being less expensive to install for that installed cost of having to trench, install conduit, and all those types of things. It works out really well. The protocol's simple. Request response works well. It also works well in that if you have a communication error, which can happen in your wireless applications, there are mechanisms within the Modbus protocol to retry. I will caution you, though, that depending upon your specific application, it will take a little bit of tuning to set up some parameters on your Modbus master. And while I didn't have a chance to go into detail on it, your Modbus master is going to have a couple options of how long do I wait for a response coming back from the slaves, and that can be very quick to a little longer, and also how many times do I retry. But absolutely, Modbus works well, whether you tunnel RTU over serial, or more importantly, it even works better with Modbus TCP, whether that's over Wi-Fi connections or even cellular connections. We have experience doing both. Martin, do we have time for one more?
Sure, we can do one more. The last question that we'll have here is again from Ken. He wants to know what kinds of distance can be used with Ethernet.
Okay, another one, and these are great questions, and I really appreciate you guys today for this, and I think, as you said, Martin, we're not going to get to all of them, and we'll have to kind of contact you after the webinar. We do want to follow up with each and every individual one. But for this question, remember, and this is back to Ethernet 101, that Ethernet itself is based on copper cabling, and we have certain properties with Ethernet that limit how far it can go. If you look at the standard per the spec, you've got 100 meters, which is just a little over 300 feet. Your mileage may vary a little more, a little less based upon your applications. If you want to go further than that, there's a lot of different things that you can do, and keep in mind that when we talk Ethernet, it's almost always coupled with utilizing TCP/IP networking. So if we talk about that lowest level, the hardware level of your network, you can do a couple of things. If you want to extend that Ethernet connection a little further, one of the best options out there is going with a Ethernet media converter. And there's a standard option of using Ethernet over fiber. So you typically, that's called an Ethernet media converter. It's going to convert your electrical signals on Cat5 cabling to fiber optic light pulses and go across that with two devices back to back. You can extend that from thousands of feet to tens of miles, dozens of kilometers if that's the case. Another technology that's kind of new here is utilizing DSL technology. We have some technology to take, much like if you have a DSL connection or broadband connection at home, you can take Ethernet and connect that over twisted pair copper cabling. For more information on that, maybe we could follow up with you separately with some solutions for that. And then lastly, remember that you have IP connectivity, and even if you're not using Ethernet and you go over whatever technology, whether it be a cellular connection or you do, I talked about oil and gas, we see a lot of satellite terminals used for that. You can move IP over lots of different technologies, and you're not tied just to that last mile or last 300 feet connection to Ethernet. Good question, Ken. I appreciate it, and I'm sorry we can't take everybody's questions again. And Martin, can you at least let us know again how we'll respond on those?
No, absolutely, Paul. As you mentioned, we are at the end of the presentation and the session. We've had more questions than we have time for. Please know that we'll get to those questions as soon as we can. We'll get them answered and responded to individually via email. Thank you, Paul. Thank you, everyone, for attending, and thank you for your interest and participation. Also, everyone will be receiving a follow-up email with both the recording and presentation slide deck. Lastly, please take a minute before logging off to fill out our survey, as we really value your input and feedback. Thanks again for tuning in, and have a great rest of the week.